Hello everyone, welcome to my channel. This is G. Varun, pursuing my education in Sri Venkateshwara College of Engineering, Bengaluru. Today, we will discuss about Heisenberg uncertainty principle. Let us dive into the topic. Introduction to Heisenberg uncertainty principle. Heisenberg uncertainty principle is a fundamental concept in quantum mechanics. It states that there is a fundamental limit to how precisely certain pairs of physical properties of a particle, such as position and momentum, can be known simultaneously. This principle was formulated by German physicist Werner Heinz Heisenberg in 1927. Heisenberg uncertainty principle. When electrons are considered particles, we should be able to measure their position and momenta accurately. But Heisenberg showed that it is not in this case. The argument seems complex, but the result is simple. The uncertainty of the position delta x and uncertainty of in momentum delta p has this relation. Delta x into delta p is greater than or equal to h by 4 pi. The implication. The position is fuzzy if we know the energy accurately. We are concerned with the energy more than we are with location. Probability of finding the electron correlates to orbital. Dual nature of the particle. Particles in quantum mechanics exhibit both wave-like and particle-like properties. The uncertainty principle arises from the wave-particle duality of the particle. It is impossible to precisely measure both the position and momentum of the particle simultaneously. Next, we will discuss about mathematical formulation. Mathematically, the uncertainty principle can be expressed as delta x. Delta p is greater than or equals to h by 2 pi, where delta x is the uncertainty in position, whereas delta p is uncertainty in momentum, and h is the Planck's constant. The product of the uncertainties in position and momentum must be greater than or equals to the reduced Planck's constant divided by 2 pi. Next, we will discuss about consequences for measurements. The uncertainty principle set a fundamental limit to the precision of measurements in quantum mechanics. The act of measuring a particle's position or momentum affects its state, making it impossible to simultaneously know both properties with arbitrary precision. This is a fundamental departure from classical physics, where precise measure of both positions and moment were thought to be impossible. Uncertainty principle. Another limitation of the Bohr's model was that it assumed we could know both the position and momentum of an electron exactly. Werner Heisenberg, developer of quantum mechanics, leads him to the observation that there is a fundamental limit to how we one can know both the position and momentum of a particle. Next, we will discuss about applications in quantum mechanics. The uncertainty principle has profound implications for the behavior of particles at the quantum level. It explains why electrons do not spiral into atomic nuclei, as their uncertainty position and momentum prevents them from precisely occupying a single orbit. The principle also underlies the concept of wave particle duality and the wave function interpreted of the particles. Next, we will discuss about technologies application. The uncertainty principle has practical applications in various fields. It is crucial in developing technologies such as electron microscope and scanning tunneling microscopes that rely on the wave-like behavior of the particle. It also plays a role in quantum cryptography and quantum computing, where the manipulation of quantum states is essential. Applications of uncertainty principle. First, non-existing of electrons in the nucleus. Second, existence of protons, neutrons, and alpha particles in the nucleus. Third, zero point energy. the minimum energy of the system at 0 Kelvin. It gives finite value of 0 point energy. Fourth, binding energy of an electron in an atom. Next, we will discuss about criticisms and interpretation. Some physicists argue that the uncertainty principle is not a fundamental limitation, but rather a reflection of our incomplete knowledge or limitations in measurement techniques. Different interpretations, such as Copenhagen interpretation and the pilot wave theory, offer alternative explanations for the uncertainty principle. The debate around the interpretation of the uncertainty principle is still going. Heisenberg uncertainty principle is also known by there is a fundamental limitation to just how precisely we can know both the positions and the momentum of the particle at the given time. Like delta x, x into delta p is greater than or equals to h by 2, where h is equals to h by 2 pi. Next, we will discuss about Heisenberg's legacy. Heisenberg's uncertainty principle revolutionized our outstanding of quantum world. It challenged classical determinants and introduced the concept of inheritance uncertainty at the fundamental level of nature. Heisenberg's work earned him the Nobel Prize in Physics in 1932. Finally, we will conclude that Heisenberg's uncertainty principle is a fundamental concept in quantum mechanics. It states that there is a limit to how precisely certain pair of physical properties of a particle can be known simultaneously. The principle has profound implications for our understanding of the quantum world and finds application in various specific and technological fields. Thank you.